Now that we've talked about exponential functions, there's another tool we really need to get at the moment. Um, and it's the inverse of an exponent. So, we have exponential functions, and that function's what we call one-to-one. So it has an inverse, and that inverse is a logarithmic function. Now, we're not going to talk too much about logarithmic functions themselves yet. I just want to introduce you to the concept of a logarithm and how it's used. So let's say we have something like 3 to the x equals 27. Okay? How do we know how to solve for x here? So, of course, what we can do is, take multiples of 3 and make a guess. And you can solve for x here. But the formal tool that we use for this is something called a logarithm. So here, this equation would turn into log base 3 of 27x. And if you punch this into a calculator, you're going to find out that this is 3. So how does a logarithm work? So let's say we have the equation. So again here, sorry, I should say that b is a positive number and b is not equal to 1. We specifically want this again. Okay? Then, if y equals b to the x, then the logarithm basically allows us to swap things around and solve for x instead. So then x equals log b of y. So this here is the logarithm with base b is this number here. Okay. And this is just a way to undo an exponential function. Right? So if we have an equation like this with an exponential function, a logarithm will undo it for us. So it's just a particular way, a particular definition we're going to have at the moment that we'll want to use. Now, the reason I bring it up is there's a very special exponential function. We call this, we have something called the natural number. Which is e. And e is about, 2.71, so on. I'll let you look up the value of this. But this number e here turns out to show up in a lot of applications. Right? So here, a very typical exponential function that we'll see a lot is the function f of x equals e to the x. Right? This is one of the most important exponential functions. Right? Actually, let me call this y equals e to the x. The reason I bring this up is there's a specific logarithm that goes along with this exponential function here. Right? So if y equals e to the x, then of course we have e equals log base e of y. But this thing right here, log base e of y, we actually specifically call this ln. This thing here is the natural logarithm. Now again, we'll see a bit later why ln is the thing we really want to deal with. It turns out to have really nice properties. But again, we'll punt that to the future for calculus. The reason I want to bring it up is our next step is going to be doing derivatives of exponential functions. So we'll really need to understand logarithms here. Okay? So we'll let's write down some last properties here for logarithms that will help us out in. So if we have b to the log base b of x power, then b and log b here cancel out and give you x. Okay. So this is one property. All these properties. That's one important property. Another important property of logarithms is that if you take log base b of b to the x power, again, these two cancel each other out. And these two right here are what it means for a logarithm and an exponential function to be inverses of each other, right? If they have the same base, the exponent or exponential function and the logarithm, then they'll cancel each other out. So specifically here, e to the ln x, x, and ln of e to the x, x. Right? That's just a special version of that. Right? There's one more property I want to mention that's very important for logarithms. Log base b of m to a power is just going to be p times that logarithm without the power on m. Okay? So I'll leave this here, and then we'll get to some derivatives of exponential functions in the next video.